Okay, so your project 5, just assigned, is to calculate volumes of 4 pieces of candy. You're going to use the method we learned today for 2 of them, and you're going to use the method we learned Wednesday for the other 2. It does not matter which candy you choose for which. Yes.
So it says to ignore the ridges on the resistance.
Okay, so we're going to study a method for finding volumes of solids that are created by revolving a 2D region about a line. And the line is called the axis of revolution. Okay, so I've got 3 two-dimensional objects here that I'm going to rotate about a line. And we want to visualize what shape is going to be formed when you perform this rotation. So here I have a rectangle, 2D shape rectangle. If you were to imagine it rotating about this line, coming out of the board and around the line, what shape would be formed when you rotate it? A cylinder. Okay, now I have a hemisphere. If you rotate it about this line, you get a sphere. It's a 3-dimensional object. It's coming right out of the board and going around the line. Okay, so now I have a right triangle. When I rotate it about the line, I get a cone. And now I have a rectangle, but it's not right on the line. So if I rotate this about the line, what am I going to get? A tube, yeah. Like a cylinder, but the center's been hollowed out, like a roll of paper towels. Okay, so let's look at some of these things like in 3D. We're going to see some animations of what these look like. Okay, so here I have a blue rectangle, or a rectangle that's very, very, very thin, right? If I rotate it about the axis of revolution, I am going to get a cylinder that is very, very, very thin. We would call this a disk. Okay, we're forming a disk when we rotate this very thin rectangle about the axis of revolution. All right, so here, same idea. If I want to rotate this equation, square root of x, about the x-axis, here's one rectangle. What would happen to that one rectangle? As I go around the x-axis, it forms a disk with the thickness of the rectangle. Here's my whole area. I want to see all the disks here. It forms like a cake, right, that estimates the volume of the area being rotated around the x-axis. And here's what it looks like, not in estimate form, but the exact area revolved around the x-axis. Oh, sorry, this time we're revolving around a different axis of revolution. The axis is not the x-axis. So instead of disks, what are these things that I'm forming? These tubes, yeah, tubes with a very little thickness. We call them washers. Good. So just a quick demonstration here. Here's my cone. It's right up against the axis of revolution. If I draw a tiny little rectangle here and rotate it about the axis of revolution, I'm going to get a disk, right? It's going to have some small amount of thickness. But if I draw a little rectangle here, a little representative rectangle, and rotate it about this axis, I'm going to reflect it. It's going to land over here when I rotate it around. So I'll get a washer. So if you take a slice of a region rotated to be rotated that is perpendicular to the axis of revolution, the shape that is generated by that slice is either a disk or a washer. Okay? And for that reason, the method we're about to see is called the method of disks and washers. So for this method, it's important to know that the volume of a disk is pi r squared times thickness, just the area of the disk times the thickness of the disk. pi r squared times thickness. And then this should say volume, sorry. The volume of a washer, you take the area of the washer, so you do the area of the large outer circle, subtract the area of the inner circle, and then multiply by the thickness. So that's the volume of a washer. All right, so I want to find the volume of the solid that is obtained when the region bounded by the square root of x, y equals the square root of x plus y equals -1, and x equals 1 and x equals 4. So I have this region bounded by all these lines. I'm going to take that area and rotate it about the line y equals 3. And then we're going to do our usual slicing process that we learned last class. So here's the region, right? So it's the square root of x. And then this line is x plus y equals -1. Label it over here. And then x equals 1 and x equals 4. So the shaded region here is bounded by those 4 curves. So it's shaded in this like reddish brown color. I want to rotate that region about the line y equals 3. So this is my axis of revolution. So I'm going to take this whole region and rotate it about that line. Okay, so rather than trying to make this problem really big, I'm going to shrink the problem a little bit by saying, okay, what's going to happen if I just do one skinny rectangle? If I just rotate one skinny rectangle about this line y equals 3, what will that look like? So I pick a random spot along the x-axis. We'll call this x sub I. Random spot along the x-axis. I'm going to draw a little rectangle here. And I want to imagine rotating it about the line y equals 3. It's going to come right out of the board, land up on top, so we'll have a reflection up above the line, and then it's going to go behind the board and sweep through, sweep around. So I'm going to draw the reflection. So up above this line, so it starts at like here-ish. And then it's going to go up to about, say this is 1, 2, 3, 4, 5-ish. Like this. So there's my rectangle reflected. So after it comes out of the board and rotates 180 degrees, you're going to see this reflection over here. And then it's going to go down behind the board and continue to circle around. So I'm going to draw a picture of what's going to form. What shape is going to form when I do this rotation? A washer. Yeah, so I'm going to draw a picture of this washer. It's going to look something like washer. Okay. So I need to find the volume of this washer. And the volume of a washer is pi times the big radius squared minus pi times the little radius squared, all times the thickness, which in this case is delta x, right? If this is x, I drew a little rectangle at an x location. Its thickness is delta x. All right, so I need to figure out what is big R and what is little r. So I need to find out the little r is the distance from 3 to the top of my rectangle, right? So what is that distance? Well, it's going to vary depending on where I picked this x value, right? Because I'm going to draw like 1,000,000 or 1,000 or 1,000,000 of these washers, starting from 1 and stacking them up until 4. So this is just a random one that I drew. So you can't say 1.2. At this specific location, it's about 1.2. But if I wanted to be more exact, what would I 3 minus square root x, yes. It's just this vertical distance, so it's the y value here minus the y value here. So the y value at the top is 3, and then the y value here is square root x because it's on the graph of y equals square root x at an x value I picked, x sub I. So capital R, see, capital R is 3 minus the square root of x sub I. Square root of the x value I picked. And I just subtract the top one minus the bottom one. Yes. Oh, yeah, sorry, that's the little r. Good. Okay, now the capital R is the bigger one. It's the distance from the 3 to this point right here. So I'll do this in a different color. 3 to this point. That distance. So it's going to be 3 minus whatever this y value is. So let me just 3 minus. Now this y value, it's on the line x plus y equals -1. So if you solve that for y, because I need the y value. I picked the x value, x sub I. I need the y value. So this would be y equals -1 minus x is the equation of that line. So my large radius is going to be 3 minus -1 minus x. Just the top y value minus the lower y value. That's how you find the vertical distance between 2 points. Larger y minus the smaller y. Any questions on what we've done so far? Okay. Okay, so the volume of my single washer. Yes. Yes, x sub I, you're correct. Okay, so the volume of my single washer is pi big R squared minus pi little r squared times delta x. Now I have a value for big R and little r. I need to make this bigger. Okay, so the volume of my washer. It is pi times big R, which we said was 3 minus, maybe I'll simplify that before I plug in. Just distribute the negative, so this becomes 3 plus 1 plus x sub I. So big R is 4 plus x sub I. Simplify it a little bit before we start plugging it into more complicated stuff. I think I'm going to jump to a new page here. Okay, so the volume of my washer is pi r squared minus pi r squared times thickness. And my big R is 3, nope, it was 4 plus xi squared. And little r is 3 minus root xi. And thickness is delta x. So I'm going to put this all into my formula for the volume of a washer. The volume of a single washer is pi times big R squared, so 4 plus xi squared, minus pi times little r squared, 3 minus root xi squared, all times delta x. So that is just a single washer. What I'm going to do is make like 1,000 of these washers and stack them up between 1 and 4. That's what they told me to do here. The region is bounded between x equals 1 and x equals 4. I drew one specific washer here, but I'm going to do one at lots of different x values. I'm going to have all these washers and I'm going to stack them up. So I'm going to have n of them, and then I'm going to let n go to infinity. I'll do 1,000 and then a 10,000 and then a million. So the volume of all my washers is just a sum of all of the single washers. So I'm going to have pi times 4 plus xi squared minus pi times 3 minus root xi squared delta x. That's one washer. I'm going to add up n of them, I going from 1 to n. And then my exact volume will be that sum as n goes to infinity. It doesn't matter because we're going to let the number go to infinity. So if you start, whether you start at 1 or 0, you're still going to have infinitely many. Okay, so the volume exact is this sum as the limit as n goes to infinity. Not going to write it all out again. And then the limit as n goes to infinity of a Riemann sum, that's an integral. That's the definition of an integral. So this is the integral. I'm going to translate a little bit here. We drop the sub i's and we change the delta x to a dx. So this becomes pi times 4 plus x squared minus pi times 3 minus root x squared dx. And then my bounds of integration is where I'm stacking these washers. I'm starting them at x equals 1, and I'm stacking them up until x equals 4. So I'm going to integrate from 1 to 4. So that integral, which would be fairly straightforward to integrate by hand, or you could just put in a calculator, that integral tells me the exact volume of that region rotated about the line y equals 3.